This is AS Stats, and we're looking at Unit 4 Probability. So just a wee introduction about the terminology and that sort of thing. So let's take a wee read through the first page. So the probability gives the likelihood that a defined event will occur. It is quantified as a positive number between 0, the event is impossible, and 1, the event is certain. If A is a defined event, then the probability of A occurring is expressed as probability of A. Capital letters are normally used to label events, and rule 1 we've just really taken down. The probability, sorry, that pencil's not going to work for me. Probability of an event happening, that's what we call E. You could of course have A in there, has to be between 0 and 1. And as you see there, 0, it's impossible, 1, it's certain. The probability of A not occurring is expressed then as P of A with a wee hat over it, or P of A prime. This is known as the complement of the event, and the probability of an event not happening is equal to 1 minus the probability of the event happening. The Venn diagram below summarizes this information. So if this is event A, then outside is going to be the probability of the event not happening. We can either calculate, let's move this down so we can read it. We can either calculate a probability through experiment or estimate it using knowledge of the situation. Theoretical probability is estimated and based on what we expect to happen. Relative frequency or experimental probability is calculated through experiment or observation. Any given experiment can result in several possible outcomes. Each possible outcome is called a sample point, and the set of all possible outcomes is called the sample space S. If S has a finite number of outcomes, we denote the number involved by n of S. If S consists of a finite number of equally likely outcomes, then the probability of an event E is defined as probability of E is NE over N of S. Put simply, this is calculated using the number of possible ways an outcome can occur divided by the total number of possible outcomes. I mean, this looks very complicated, but it's very, very straightforward. The probability of rolling a 4 on a dice, how many 4s are there? There's going to be 1. How many possible outcomes are there? There's going to be 6. So that then would just be 1 over 6.